Connecting a 20 amp generator to a 30 amp transfer switch requires careful consideration to ensure safety and prevent damage. The generator's output is rated for 20 amps, while the transfer switch is rated for 30 amps. Directly connecting the 20 amp generator to the 30 amp transfer switch presents potential problems related to current limits, plug-in compatibility, and overall safety concerns. Exceeding the generator's current limit can cause damage. The generator is designed to output a maximum of 20 amps. If the transfer switch and connected loads demand more than that, the generator could be overloaded. This can lead to overheating of the generator's internal components, potentially shortening its lifespan or causing permanent damage. The 4-prong plug that came with the generator is designed for a 20 amp connection, while the transfer switch requires a 30 amp plug. Attempting to force a 20 amp plug into a 30 amp receptacle could result in a loose connection. Loose connections create resistance, which generates heat. This overheating can melt the plug or receptacle, creating a fire hazard. Using an incompatible plug could also damage the transfer switch. Exceeding the current limit of the generator or using an incompatible plug creates safety hazards. Overloaded electrical circuits are a leading cause of electrical fires. Incompatible connections can also pose a risk of electrical shock. To safely power the transfer switch with the 20 amp generator, it is recommended to install a step-up adapter. Purchase a 20 amp NEM-L14-20 to 30 amp NEM-L14-30 step-up adapter. This adapter allows you to connect the generator to the transfer switch while maintaining the correct current rating. This adapter ensures that the generator is not overloaded and that the connection is safe and secure. Ensure that the cord used between the generator and the transfer switch is rated for at least 30 amps and is suitable for outdoor use. A heavy-duty cord is essential for safely transferring power from the generator to the transfer switch. The cord should be rated for at least 30 amps to handle the potential current draw of the connected loads. It should also be suitable for outdoor use, meaning it is resistant to moisture, abrasion, and UV radiation. Using a cord that is not rated for the appropriate amperage or outdoor use could create a fire hazard or result in electrical shock. Refer to the manufacturer's instructions for both the generator and the transfer switch to ensure proper setup and operation. The manufacturer's instructions provide specific guidance on how to safely connect and operate the generator and transfer switch. These instructions may include information on grounding, wiring, and other important safety precautions. Failing to follow the manufacturer's instructions could void the warranty and create a safety hazard. Prioritizing safety is crucial when working with electrical equipment. Adhering to recommended current ratings and configurations minimizes the risk of electrical fires, shock, and equipment damage. Never exceed the generator's current limit or use incompatible plugs. Always use a step-up adapter and heavy-duty cord to ensure a safe and reliable connection. In addition to the previous recommendations, it's important to understand some electrical concepts related to generators and transfer switches. Firstly, voltage refers to the electrical potential difference between 2 points in a circuit. In residential settings, common voltages are 120 volts and 240 volts. Generators can supply either or both voltages depending on their design. Secondly, amperage measures the flow of electrical current in a circuit. It's directly related to the amount of power being consumed. Higher amperage indicates a greater flow of current. Thirdly, wattage represents the amount of electrical power being used. It's calculated by multiplying voltage by amperage. A 2500 watt generator can supply a maximum of 2500 watts of power. Transfer switches are designed to safely switch between the utility power grid and a backup power source such as a generator. They prevent backfeeding, which is the dangerous situation where power from the generator flows back into the utility grid. Backfeeding can energize power lines, posing a risk to utility workers and the public. Transfer switches also allow you to selectively power essential circuits in your home during a power outage. These circuits might include lighting, refrigerators, and medical equipment. When selecting a generator and transfer switch, it's essential to consider the power requirements of your essential circuits. Add up the wattage of all the appliances and devices you want to power simultaneously. Choose a generator with a wattage rating that exceeds this total. Also, ensure that the transfer switch is rated for the appropriate amperage and voltage. When connecting a generator to a transfer switch, follow these steps. Firstly, turn off all breakers in the transfer switch. This prevents a surge of power when the generator is started. Secondly, connect the generator to the transfer switch using the appropriate adapter and heavy-duty cord. Ensure that the connections are tight and secure. Thirdly, start the generator and let it warm up for a few minutes. Fourthly, turn on the breakers in the transfer switch one at a time, starting with the most essential circuits. Monitor the generator's load to ensure that it's not being overloaded. If the generator starts to strain, turn off some of the breakers to reduce the load. When utility power is restored, follow these steps to switch back. Firstly, turn off all breakers in the transfer switch. Secondly, turn off the generator and let it cool down. Thirdly, disconnect the generator from the transfer switch. Fourthly, turn on the main breaker in the transfer switch to restore power from the utility grid. Regularly inspect the generator, transfer switch, and cords for any signs of damage. Look for frayed wires, cracked plugs, and loose connections. Replace any damaged components immediately. Also, keep the generator clean and free of debris. Store it in a dry, well-ventilated area when not in use. When operating a generator, be aware of the risk of carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be deadly. Never operate a generator indoors or in an enclosed space. Always operate it outdoors in a well-ventilated area. Install carbon monoxide detectors in your home to provide an early warning of dangerous carbon monoxide levels. Test the detectors regularly to ensure that they are functioning properly. In conclusion, safely connecting a 20 amp generator to a 30 amp transfer switch requires careful planning and execution. Using a step-up adapter, heavy-duty cord, and following the manufacturer's instructions are essential steps. Understanding basic electrical concepts and taking precautions against electrical hazards and carbon monoxide poisoning are also crucial for ensuring a safe and reliable backup power system. Remember that electrical work can be dangerous. If you are not comfortable performing any of these tasks, consult a qualified electrician. A professional electrician can assess your power needs, recommend the appropriate equipment, and install it safely and correctly. They can also provide guidance on operating and maintaining your backup power system. Investing in a professional installation can provide peace of mind and ensure that your backup power system is safe and reliable. Furthermore, consider these additional safety tips when using a generator. Never refuel the generator while it is running or hot. Allow it to cool down completely before adding fuel. Use only the type of fuel recommended by the manufacturer. Store fuel in a safe, approved container away from the generator and other potential sources of ignition. Keep children and pets away from the generator and cords. The generator can get hot and the cords can pose a tripping hazard. Never try to modify the generator or transfer switch in any way. This could void the warranty and create a safety hazard. If you have any questions or concerns about your generator or transfer switch, consult a qualified electrician or the manufacturer. Taking these precautions will help you to safely and effectively use your generator to provide backup power during outages. Also, be sure to check your local building codes and regulations regarding the installation and use of generators. Some jurisdictions may have specific requirements for venting, noise levels, and other safety considerations. Complying with these regulations will help to ensure that your backup power system is safe and legal. Remember that a generator is a powerful tool, but it must be used with caution and respect. By following these guidelines, you can protect yourself, your family, and your property from the hazards associated with generator use. In addition to the electrical safety aspects, it's also important to consider the mechanical safety of the generator itself. Regularly inspect the generator for any signs of damage, such as cracks, leaks, or loose parts. Pay particular attention to the engine, fuel lines, and exhaust system. If you notice any problems, have the generator repaired by a qualified mechanic before using it. Keep the generator clean and free of debris. Dirt, dust, and leaves can accumulate in the engine and other components, causing them to overheat or malfunction. Clean the generator regularly with a brush or vacuum cleaner. When storing the generator, protect it from the elements. Cover it with a tarp or store it in a shed or garage. This will help to prevent rust, corrosion, and other damage. Also, drain the fuel tank before storing the generator for an extended period. This will prevent the fuel from deteriorating and clogging the engine. Before using the generator after it has been stored, check the oil level and add oil if necessary. Also, check the air filter and clean or replace it if it is dirty. By taking care of the mechanical aspects of the generator, you can help to ensure that it will operate reliably and safely for many years to come. Finally, remember that a generator is not a substitute for the utility power grid. It is intended to be used only as a temporary backup power source during outages. Do not rely on the generator as your primary source of power. If you have frequent or prolonged power outages, consider investing in a permanent standby generator. A permanent standby generator is automatically installed and connected to your home's electrical system. It will start automatically when the power goes out and shut off automatically when the power is restored. A permanent standby generator provides a more convenient and reliable backup power solution than a portable generator. However, it is also more expensive. If you are considering a permanent standby generator, consult a qualified electrician to determine the appropriate size and model for your needs. The electrician can also install the generator and connect it to your home's electrical system. A properly installed and maintained permanent standby generator can provide peace of mind and protect your home from the inconvenience and hazards of power outages. Remember that electrical safety is always the top priority. If you have any questions or concerns about your generator or transfer switch, consult a qualified electrician. They can provide expert advice and assistance to ensure that your backup power system is safe and reliable.